Okay, we are going to continue with bonding, ionic bonding and ionic formulas actually. We did binomial ionic formulas, now we're going to talk about polyatomic ionic formulas. These are formulas that contain something called a polyatomic ion. Poly meaning more than one, and atomic meaning atoms. So these are ions that are made up of more than one atom. Okay, as you can see here, ammonium is made up of nitrogen and 4 hydrogen, and when those combine together, they do so, but they're not completely happy because they still have a +1 charge, and they want to get rid of that +1 charge and become and bond with something so that it's the overall total of that compound would be a 0, just like other ionic compounds. So these ones that are starred here, and I'm going to give you guys this sheet of paper, are ones that we're going to use very often. You're going to use this to refer back to the sheet that I give you. These are ones that I highly suggest memorizing because you're going to use them very often, and I'm going to get frustrated if I have to keep saying it over and over and check your paper. Alright, so let me go over what a polyatomic ion is, or polyatomic ion compounds. The charges still have to balance out when you have a polyatomic ion compound. Okay? So here are some hints. If there are more than 2 capital letters, you have a polyatomic ion compound. I'll show you on the next page what that means. Another hint, when you're writing the polyatomic ions formula, put the symbols and subscripts in parentheses and the oxidation number outside the parentheses. This hint has to do more with if you're given the formula and you have to come up with the name, which I'll go over in a moment. This one is if you're given the name and you have to come up with the formula, like we were doing for the ionic compounds, all right? Or the binomial ionic compounds. All right, so what does this mean? So let's say I give you magnesium phosphate. Magnesium is just magnesium, so that's Mg with a +2 charge because it's in group 2, has 2 valence electrons, which will lose very easily, and when it loses them, it now has 2 more positives than it does negatives, hence the +2. Phosphate, which was on the page right here, phosphate, right here, is a PO4 with a -3 charge. Now, writing it like this gives people the impression that only the O4 has a -3 charge. But it's actually the whole thing, PO4, that is a -3 charge. And that's why I said put it in parentheses. So I put it in parentheses here. So PO4 has a -3 charge. Now the rules apply with the crossing to cancel out. In this case, they don't cancel each other out just by looking at them. It's not +2 and +2, it's +2 and -3. So you have to do the crossing down. And to do that, you'd put the absolute value of this charge right here, which is a 2, and the absolute value of this charge right here, which is a 3. And that's how you get your answer of Mg3PO4 2. I have examples of these, and I want you to do those. So once you do the next slide, you're going to get the examples from me. So let's go to the next slide. And I have no problem going over this with you guys, doing several examples with you on the worksheets that I have. So just see me, okay? All right, so let's go to the next thing, actually coming up with the name based on the formula. So you have the formula, now you got to write down what it says, okay? So before it was Mg3PO4 2. If you're just looking at that, you should be able to tell me that it's magnesium phosphate. Why? The first element, which is always going to be a metal, is going to stay the same. So whatever that element is, in this case down here, iron, it's going to be iron, okay? The second element is the nonmetal, or the polyatomic ion. The nonmetal is going to end in IDE. The polyatomic ion has different rules. We'll get to that in a second. If the metal is a transition metal, like iron right here, you have to put the oxidation number as a Roman numeral. So you look, make sure it is. First thing you do is check to see if it's a transition metal. Iron is. Find the charge of the nonmetal. So the charge of the nonmetal, oxygen, it's in group 6, so it would have a oxidation number or a charge of -2 because it needs 2 more valence electrons to get to 8, which it wants to. If there isn't a subscript, the oxidation number is the opposite of the charge of the nonmetal. So if there were no subscripts here, and we know Fe, it was FeO, okay? We know O has a -2 charge, so then we would know, okay, this must have a +2 because there's no subscripts, okay? If there is a subscript, like it says here, you do the crisscross. Okay, so the answer for this, if I was to write it, would be, and here I go with my terrible stylus control, this would be iron, Roman numeral 3, because the 3 crosses up, and that's its oxidation number. It's a +3 charge. 1, 2, 3. And the second part would be oxide, because it is a compound now. Okay? Because if I was just to say iron 3 oxygen, then it just sounds like I'm listing the different elements. I know I said that in the other video. Okay? So that is ionic compounds. I just want to go to one more thing about polyatomic ions. If you are naming something where you see there's more than 2 capital letters, like I had mentioned a couple of slides ago, there's 3 capital letters to say. Now you know that the second half is going to be the polyatomic ion, more than likely. The first one is usually going to be a metal. You can have 2 polyatomic ions. You can have a positive one followed by a negative one. And if you see like 4 capital letters, then that means you have a double polyatomic ion. It happens. Don't freak out. When bonding with a polyatomic ion, which is usually negative, the name of that anion, that polyatomic anion, does not get an IDE, it just stays the same. So magnesium phosphate, you don't call it phosphatide, okay? You still have to make the overall charge equal to 0. And that's pretty much it for ionic. We will go into covalent next. You'll be surprised at how much easier covalent bonds are, all right? So, go have fun. Get the worksheet from me, and don't cry. All right, I'll help you through it. Bye.